This is an introduction video into ellipses. So we've already gone over circles, and so we've kind of went over these shapes here. Your circle is when you cut this perpendicular to the top and bottom, so it makes this perfect circle. But if you go a little bit at an angle here, you get an ellipse. And so your definition of an ellipse is the collection of all points of the plane, the sum of whose distance from two fixed points called the foci are constant. Okay, so unlike the circle, this is obviously not equal distance from the circle. This is much closer than this is here. What this definition is telling you is that whose distance from two fixed points is constant. No matter where you put a point on this ellipse, so in this case, they put one here. This distance, if I called this D1, plus this distance here, let's call it D2, are going to be a constant distance, and that constant distance is going to be 2a. So if I did D1 plus D2, we would get 2a no matter where I am on this ellipse. So if I did a point over here, this distance plus this distance would be the same as these two distances. If I did a point right here, this distance plus this distance is the same, no matter where that point is. From that point to your two foci, which is just plural for focus, is the same. We don't really need to know that. We don't really need to know this D1 plus D2 equals 2a, but that is what the definition is stating. Okay, so that's the only reason I go into that. What we do need to pay attention to is that you do have a major and minor focus here. Your major focus is the major side of this. So your major axis is where this circle, if you will, you take this, that's bad, you take this circle and you just stretch it out in one way. So wherever you're kind of taking that circle at the vertices and you're stretching it, that's where that major axis is. Now this textbook will only call those 2 points, the furthest away from the center, your vertices. I kind of refer to those as your major vertices. And then you have a minor axis, which is where the shortest distance from the center is going to be. And it's not put on here, but I would call that your major or your minor vertex 1 and your minor vertex 2. And so you represent major vertex with a capital N and a minor vertex with a lowercase n. When we go into graph, we need all 7 of these points. We need to know where the center is. We need to know where your major axis or your major vertices are. And we will actually make a note of where that major axis is. It's either going to be along the x-axis or the y-axis, or parallel to. And then we need to put our minor vertices. Okay, and I'm sorry guys, I sound like this, but I am still sick. Okay, and then along with your 4 vertices, your 2 major, your 2 minor, and the center, you also need both foci. The foci are not really important as far as what the shape of this looks like. The shape is going to come down to your major and minor vertices. But because that ellipse, that focus is so important in the definition, we need to label those as well. So you're going to label all 4 vertices, major, the 2 major, the 2 minor, the 2 foci, and the center.